Next talk. All right. Hi, everyone. I'm Peter Allwin. I work as a dev manager at Viaplay. And I want to talk to you a little bit about a sous vide that I built using JavaScript. So for those of you who don't know, a sous vide is a way of cooking food where you put your food into plastic bags. You stick it into this temperature-controlled water bath, wait for a while, and what happens is that the food cooks evenly throughout and also retains a lot of the moisture, a lot of the texture from what it had from before. So it's a really nice way of cooking. It produces great food, and it's pretty simple to do. So these are commercial units, looking very commercial, pretty fun. I figured why not build our own and see how that works out. All right. So the key thing here is to control the temperature of the water. So we need a thermometer in the water bath. We want to connect that to our Raspberry Pi that we're using. We need to put the water bath on some kind of a heater to heat the water. And we need to control that with our Raspberry Pi as well. So for temperature, we use this thermistor that I soldered together. It's basically a resistor that changes the resistance with the temperature. We need an analog digital converter, since the Raspberry Pi doesn't have analog input. And we solder it up, go to software side. Well, we can't just read from the analog digital converter from Node, so we need to build this V8 add-on, which is kind of fun. So you get to do some I/O control calls and stuff here on Linux. But once you've done that, look at this. You can just read the resistance from a callback. Very fun. We have the resistance. We need the temperature. There's a nice data sheet that comes with a little thing you buy for $1, and you have to type all this stuff into your program. Alrighty, heater side. So my trusty Menuet that I bought at Jula for $199. You switch it with this solid-state relay, which is kind of a cool thing. It's like a regular relay, but it's basically like a giant transistor. So it's quiet. It doesn't produce any heat. It's good stuff. At this point, you put your high-voltage stuff in this repurposed box and keep it away from the water for as long as you can. All right, so we can control the temperature now maybe by doing this program. So I read the temperature. If it's below what I've set it to, I turn the heater on. If it's above, I turn it off. Let's run it. Well, turns out we get this little weird graph here where since it takes a little while before or after I turn on the heater before the heat actually comes into the water, by the time I turn it off, I've accumulated too much heat, so I'm going to have this oscillation going on, and that's not what I want. So, turns out someone fixed this in like 1890s with this fantastic thing. It's called a PID Controller. It looks at the integrated error over time, and it also looks at the derivative over time. So you can implement that in JavaScript here after you Googled for a bit and copied from some other project that did basically the same thing. These tuning parameters, by the way, trial and error, so prepare for long nights. But you put it all together, you stick it in your little homemade thing here, you watch it blink, which is so satisfying. Therapy for geeks. And look at this. This is actual screenshot. Wow. Yeah, I was as surprised as many other people. So yeah, repurposed 1890s technology. You can see the heater duty cycle goes down and all kinds of fun stuff. So yeah, great success. This is not mine, but cooking like it's like I made this beforehand. Someone else did. And that's it. Thank you very much. If you have questions or anything, come back to our Viaplay booth and have a chit-chat. Cool.
Thank you, Peter. Please welcome to the stage Johanna and Maria.